the solutions. And I put little arrows on it to show it's not just this number and this number, it's everything between there, the fractional amount, plus everything on to both infinities. All right? So that's a little overview just to get you thinking about what a graph is. Another way to think of domain and range, for some people, this discussion hits them best. They see it with numbers, real time, what you plug in, what you get out. For other people, they're more visual, and this helps them to read domain and range. They look at this graph, and domain is the x values, right? The left, right. So you say, how far is this thing going? Left and right. And it's opening up to the left and right without bounds. So you can see the infinities left and right. And then for the range is the low to high. How low and how high is this going? It's going down to a negative infinity and up to a positive infinity. Now, you have probably been trained to graph linear equations with other methods besides just point plotting. Now, we didn't even really think real hard about this even. We could kind of just think what adds up to be 7 off the top of our head. But sometimes the equations are harder, like maybe 2x plus 3y equals 20. I don't know those combos off the top of my head. I can't tell you what you double and then 3 times another number that gives me 20. I mean, maybe you do if you think about it, and you might think of some combos. But anyway, usually the method we use is, if we're going to do a t-table, we specifically name some x or y values, plug it in, and then equation solve to see what sister companion comes up with it. So a lot of times we'll do the zeros. Plug in 0 for x gives me 2 times 0 plus 3y equals 20. 2 times 0 then just kind of drops out of 0. And it didn't come out just right anyway. You know, it came out as a fraction. That's okay. 20/3 or 6 2/3. We would say that that is the y-intercept. When you plug in x is 0, it outputs your y-intercept. If you're asked to graph by intercepts, that's what they're talking about. And we could also graph the x-intercept by plugging in y is 0. So 2x plus 3 times 0 equals 20. 3 times 0 just kind of cancels out, equals 20. And we can see now, oh, there's a combo. When x is 10 and y is 0, it solves that. Does anybody just happen to get your wheels turning and you think of a combo? Anybody think of something that works? That comes up. 7 and 2 work?
Yeah.
I think it does. I think it does. When you plug in 7 for x and 2 for y, that would give you 20. Anybody else? I'm challenging you now, right? So anybody else have one? But you don't have to think about it if you don't want to, because we always have this nice equation solving technique. You can plug in anything for x, see what it outputs for y, and just use that process. So let's say, now we've already determined, and you're going to remember, right, that the domain for a linear equation is anything, negative infinity to positive infinity. So I can pick any number that I feel like to plug in for x, and I should get an output for y. You usually just want to pick numbers that are easy to fit on your paper, though, so you don't usually pick 100 because of that, but you could. Let me just do 6. So I say I plug in 6, let's do negative 6. Negative 6 for x, 2 times negative 6 plus 3y has to equal 20. So 2, let's do that. 2 times negative 6 is negative 12, plus 3y equals 20. Bring the 12 over, 3y is 32. Divide out by 3, 32/3. We don't like those fractions, but sometimes they just happen. Anyway, it'd be a little more than 10, and so we could estimate that. We wouldn't have to get our ruler out and make it exactly fractional perfect, but it gives us an idea of where it should plot. Okay, and vice versa, if I want to, I can plug in numbers on the y side. You're always free to plug in on either side of the equation. Some equations it will be easier to plug in and output on the other side, but you always have that freedom to plug in on either side of the equation. So let's say I pick a number for y. Let's pick 7. Plug in 7 for y, I'll have 2x plus 3 times 7 to equal 20. 2x plus 21. You know, do your equation solving thing. And I just keep picking numbers that come out as fractions, but that's okay. I prefer to get you some nice points, but anyway, it comes out to be negative a half. Now, I can continue down this route, and you all just tell me that you got that. Domain is anything I want, I can plug in for x, and range is anything for y. There's no limits on this equation. We're going to see some here in a little bit, and some other equations, but the linear is our first one that we studied. You've probably seen it in your past, so we're revisiting that. The neat thing that makes your linear equation easier is its slope is constant. You know, it's perfectly straight, right? So its slant on it, or its slope, is constant. So we are able to determine the exact slope of a line with another method as well. One way is to take 2 points and see what the average rise over run is. How far did it change on the up to the over? So the change in y over the change in x is a formula for finding the slope of any line. And we use m for slope, subtract the y's over subtract the x's. Or that is the change in y over the change in x. How far up over the over, or the rise to run. And we consider this to be a negative slope. As you read the graph from left to right, it is going downhill, so that's a negative slope, and it can be verified with this picking 2 points and subtracting. Okay, another way of determining the slope of a line, that you've probably done this in your past as well. You may remember another way we can rearrange this and see the slope algebraically. Y equals mx plus b is a base formula for graphing a line. If you solve any linear equation for y, the slope shows up in front of the x every time. And the b, do you remember what it is? Y-intercept. So you're able to see 2 very important details about your graph, and you can actually just graph it from those details. So in this equation, I would throw the 2x over, divide out by 3, and I would have the slope negative 2/3 and 20 over 3, the y-intercept. And I could plot the y-intercept, start at that point, and then rise over run from that point to actually draw the whole line if you wanted to. All right, any thoughts on that? Okay, so now I want to take you into what's really in your note packet. I'm going to pause it and start it up.